So 3.6, the review. Let's see how we do. So use the data to answer the following question. So can I just plug it into the calculator and go from there? Again, I have to sit here and do it because this calculator on this one doesn't work quite as well as it should. But we'll make it all right. Make it really big screen. All right. All right. So plugging the data in, I got 135, 6, 9, 9, and 12. Just by looking at the data right off the bat, what do you notice about the data off the bat? Not plugging into any other data, any information into the calculator. What do you notice off the data that you could probably answer a question with? Yeah, the mode is 9. Okay, it's not bimodal because we don't have two of the same repeating number. So once we have this, on a short list, it might be pretty easy to find the middle. The middle of our list is already in order, is 6. But once we do this, plug it in, go stat, calculate one variable statistics, and then it's good practice to just say that it's going to go into list 1 and hit enter. And so we found that the average is 6.42. Some might notice on some of your quizzes, some of you are ignoring decimals. So just be aware, like this says 6.4, don't just say it's 6. Take it at 1 or 2 decimals. And then the median is the middle piece of our data. So if I scroll down a little bit, the median is 6, which we already said. We could see that easily. The mode is 9 because it happens more often. The IQR, how do we find the IQR? Q3 minus Q1. So Q3 is 9, Q1 is 3, 9 minus 3 is 6. So my IQR. And then we had a snort of a laugh. That's awesome. Okay. You doing all right back there? You know what's kind of fun about that? About 4.5 minutes into the video, we have it on. She's dying over there. Are you all right over there? Share with us. What's the story? It sounds so awesome. Don't get anyone in trouble, though. You got kids with their heads down just dying back there. Alright. Here's a question for you. Which standard deviation should I use of these two? Why?
There's 2 of them?
Well, there's 2 standard deviations. One of them has n, and one is using n minus 1. When do we use n minus 1? Population. Is this a population? No. So we're using n. So if I divide by n versus n minus 1, if I had the number like 20 that I was going to divide by, and I divided by 19 instead, does 19 as a denominator have a larger number or a smaller number?
Larger.
So 20 divided by, or 100 divided by 20 is 5. 100 divided by 19, is that bigger than 5?
Yes.
Yes. So then we have the square root of it. So which of those are we using, the bigger or the smaller? Is this a population we're using? So we're dividing by n. So we should use, this should be our standard deviation we're using because it's not a population. I'm dividing by n, not n minus 1 to get this one.
Yeah, so
I say use? Oh, man.
You said always use a smaller one if it's not population.
No, I don't. No. That's what sometimes happens. How did I say the? Why did I say the opposite? Hang on. Let me make this. Let me make it work. Let me make it work for you guys. Okay. So, by definition, you divide by this or you divide by this. So if I had this versus this, so if this was 100 over 19 and this was 100 over 20, this is going to be 5 point something, and this will be 5 exactly. And then if I were to take the square root of this and square root of this, which one of those would allow us to have a larger number? Is 5 point a decimal bigger than 5? Yes. So does this have a larger or a larger answer if we take the square root of it? So this has a larger.
But what's what? What's sample? What's the squiggly thing?
So one's a population.
But which one of those? N or N?
If you have n minus 1, this is a population.
Okay.
For the most part. And what it really starts coming down to is if you have an enormous set of data, it's not going to matter. The larger amount of samples we have, the closer and closer these get together.
Okay. So it was, you were right yesterday. It's the smaller number.
It's a smaller number. It was a smaller number. That's what I said yesterday.
Yeah.
What happened to me between yesterday and today? So the smaller.
You said it was, I don't know, I think it's because you mixed it up in the calculator. You know how it's weird? You said
Yes. So the smaller is the one that we're going to use.
Okay.
Right?
Yeah.
Right?
Yeah.
What you know. So the smaller answer is the one we're using because we did not divide by n minus 1. We divided by n. So this will be, this is a smaller n, right?
Yeah.
Right? Did I say that right?
What?
Now you,
Why don't-
but then,
I don't even know what we're talking
But
about.
then you're saying that that one's population and the other one's a sample. So that's why it's.
So so the population we're dividing by n minus
That's
1,
the bigger number.
which would create a larger number.
Okay.
Because that eliminates it has to do with something called degrees of freedom, which we're like, so 5 chapters away from.
Okay.
All right. What would the upper limit be for an outlier? What would the upper limit be for an outlier? So the upper limit, if we remember, this is going to be Q3 plus 1.5 IQR. Right? What was Q3 on our data? 9 plus 1.5. What was the IQR? Was it 6? 1.5 times 6 is 9. Right? So my 18 would be my upper limit for an outlier. So of my data being 1, 3, 5, 6, 9, 9, 12, is there an outlier to the top? No, it has to be beyond 18. Okay? And then if I wanted to find the lower, that's going to be Q1 minus 1.5 times 6. What was Q1 in this one? I know I didn't ask for it, but what was Q1? 3. And then 3 minus 1.5 times 6. 1.5 times 6 is how much? 9, yeah. So negative 6 should be my bottom of my data set for any outliers. And again, we don't have any outliers of this data set. Hey, everyone hide. Cool. Ooh, Hoban. Not my class anymore. I don't wish. All right, answer the following: true or false? The mean is not a resistant measure of center. The mean is not a resistant measure of center. True or false? Can the mean move? The mean is the one that moves the most. So is the mean is not resistant. It's not going to resist. So true or false? True. We have not in there. Mean, if it said the mean is resistant of the center of measure, that would be false, but because it's not, we have in there. We have a double negative going on. Data that are skewed left will likely result in a lower mean than median. So if it's skewed to the left, is it pulling the mean left? So that's a true statement. The mode works very well with continuous data. What is continuous data? What? Okay. So the mode works really well with that. Could I have like 3.56, 3.56, 3.56 as numbers? I don't like that question. I'm not even gonna answer that because I would say if we have continuous data, but it's possible that you could have a mode of data that happens to be a decimal. There's no reason why you shouldn't. I mean, infinite numbers happen with whole numbers. Infinite numbers happen with decimals and fractions as well. So, when the data are skewed right, the mode will be the highest measure of the center. When the data is skewed right, the mode. Does mode have anything to do with the mean? Anything to do with the median? Does it have anything to do with it being skewed right or left? No, so that's false. Half of the data must be above the mean and half below the mean. Huh? False. Why? The median, half the data is above, half below. The mean is just the average. You don't necessarily have half above and below it. In uniform distribution, the mean, median, and mode are all the same value. I like that answer, can be. I don't like having mode in there that much. I mean, theoretically, it should happen that way, but you could also have uniform data, and you could have it be... No, take it back. Let's go with true. And I want to go true for this reason. If our picture looked like this, the most occurring information is here. It's the highest point. If it was bimodal, it would look like this. So you'd have the same amount of information happening here as here. So the mode would have to happen here. So I would say that would be a correct thing to state, that the mean, the median, and the mode will be the same thing if you have uniform distribution. If the data are skewed, then the median is more useful measure of the center. That's absolutely true. Again, you have to go with, if you have something that's pulling it to the right or to the left, use the median for your information rather than the mean. Using the stem leaf to the right, fine. What is the mean? Well, we have to add 10, 15, 17, 21, 21, 21, 23, 30, and 41 together and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyone find the mean on number 3 that wants to shout it out? 21.77? What?
It was the same thing.
Oh, we did.
Yeah, hers is 22, mine was
21.7?
21.7.
Okay. The median, the middle of the data. Anyone know? 4, 5. 21? So it's the 5th number. So if you count 10, 15, 17, 21, 21, that's your middle. Or if you go 41, 30, 23, 21, 21, then I get the median. The mode, the most occurring number in that set is 21. The range goes from 41 to 10, so the range is 31. 41 minus 10. The IQR, you want to find that? 26.5. That's Q3 minus what? 14.5. What's that give me? 12? And then the shape of the distribution. So if you made that shape this way, if I drew this, what does it look like? Skew right, okay? Basically, I took the stem and leaf and I turned it sideways. And that's basically what it looks like. So it looks like it's a skew right data if I made this out of it, or if I made it as a histogram. Either way is going to show us a skew right. Okay? What's that? How do I know what? Is it skew right? Okay. That's what it sounded like you said. What shape would each of the following distributions have? This is problem number 4. The mean is 12. So if we had a mean being 12, a median being 14, and a mode 16. It's actually going to look like this. This is not what it looks like. It looks like this one. So the mean, the median, and then the mode is that. Skew right or skew left? If the mean is to the left of the median, skew left. Good. B, 121 is the average, the median's 115, and the mode is 112. So the mean is to the right of the median, skew right. Letter C, 72, 72, 72. That is called what? What was a uniform graph called? Uniform. Yep, all the same number. Good. Identify whether the variable is qualitative or quantitative. If quantitative, tell me if it is discrete or continuous. Okay, so wait. Quantitative is a numeric value, right? And then if it's discrete, it's like a whole number, and if it's continuous, you include the decimals and fractions, right? Qualitative is like counting cars in a parking lot. Number of people in a room. Quantitative is discrete. We don't have half a person. Some people might have half a brain, but wait. Quantitative, continuous. Time to run a mile. Continuous. Quantitative again. Eye color. Qualitative. Number of cars in the parking lot. Quantitative, discrete. Distance you can throw a football. Quantitative, continuous. Sweet. On the back side, identify each level of measure of Muir. What's Muir? Yeah, nominal, ordinal. I gotta look at the quiz because that's what it was on. So nominal, ordinal, interval, or ratio. So amount of snowfall this winter. Amount of snowfall. And remember, these were. What's that? Let me flip back a couple pages. Squeeze back in here. What were the notes on this? 3.3 maybe? 3.4? So nominal is the lowest level. It's categorical. So like hair color or ski resorts. Put in categories ordinal. Some order differences cannot determine or are meaningless. High school rank. Interval is order the data, compare the values like ordinal, but can determine meaningful differences. No starting point. There's no zero. And then ratio, similar to interval, but includes zero. Okay, so 3.6. The amount of snowfall this winter. Can we have 0 inches of snowfall? Yeah, so this has to go with ratio. Because you could have 0 inches of snow. Ratio, but you include 0. So definition of ratio is similar to interval, but you include 0. Okay? Which type of ski pass? So that would be nominal. Okay? Time spent on a lift line. So I'd say that's interval because you're probably going to have a little bit of time. If any of you ski, you don't need to do a line. Height of a ski jump. Ratio. I go with that because it could be 0.
But that's not a jump then. So
That's what?
that wouldn't be a jump then.
Well, okay, let's go this. I'm trying to think. Let's say you have the bump out there that if you hit it with a certain amount of speed, you will launch. But if you don't, you just go right over the top of it.
But that's not what it's saying.
Okay. It says
It's
height.
ski jump.
Oh, height.
If it was a ski bump that you can jump off of, that'd be different.
Okay. So, what do you think it is?
I think it's interval.
Okay, I'll go with that. Guidebook rating ski resorts area poor, fair, good. Nominal or ordinal?
Ordinal.
Yeah, so you have high school ranking, like high school rank, so you have a rank in there. How you doing, Cupcake? Hey, very little. He is not here today. Temperature at the top of the mountain. Interval. Or ratio.
Is it going to be 0? Oh, yeah.
Yeah. Let's go ratio on that. Year your skis were purchased. Ordinal. I like it. Okay. Find the following scores. Are we okay on number 7, or does anyone need me to do it? Does anyone need me to do number 8? Number 8, what were the high and low scores? The highest score was 99, the low score was 62. What are the middle 50% scores? They go between 70 and 91. Remember the boxes? Each box represents 25% of the data. What is the range? 99 minus 62, so that's 37. What scores are below Q1? Scores that are less than 70. And what do you think the average? Do you think the average score is above or below 82? Below. Why do you think that? You're absolutely right. But why? The box is bigger to the left, so something's pulling it to the left. Is everyone okay with the stem and leaf? Or do we need to do it?
Can you do
E? It's the hardest one. Make the box plot of the data.
Is that just making like the history?
Or no, making the
Is that the thing from
box whisker.
So, okay.
You're good with that?
What was that? Do you just plug into your calculator and then color what price made it will look like? But
Perfect.
it didn't have any like numerical values.
Right, but you can go Q1, Q2, or
Oh, okay.
maximum.
Yeah.
Okay. Anything else? All right. Shake it off a minute. Yeah, just enough time to start. 4.1 is relatively a simple thing. 4.1 starts talking about a few things on your calculator. Usually when you plot data, you're using quadrant 1. Okay, you don't normally have negative data, though you could. All right. So if we were to look at an R value, This is about 1. This is an R value that's probably greater than 50%. And this is an R value that is close to 0. This is also R close to 0. Go over that in a second. This is R is probably less than negative 0.5. And this is R is about negative 1. Okay? So, R values stand for this. It's how good do you think your data would fit to a line of best fit. Okay? Now, I am differing between another statistics teacher and I on R versus R squared. I think, and I might be wrong, but I'll let you know if I'm wrong, and I don't think this is going to hamper you on a test in the future, but I think R values only work when you have your data as a linear comparison. You're trying to find a line of best fit, a straight line, y equals mx plus b. Okay? The R squared value can be used for a straight line to a quadratic to exponential to logarithmic, but I might be wrong. But here is the difference between R and R squared. R times R is equal to R squared. So if I told you you had an R value of 0.7, what would R squared equal? 0.7 squared, which is 0.49. R squared values are not negative, because if I square a negative number, I get a positive. Okay? So, what we're going to plot some data here. I'm going to go with the price versus sales. So I'm going to go on my calculator stat. I am on section 4.1 if you follow along. Edit. I'm going to go to the top, go to the bottom, hit clear. All right, so price is going to be called the X value. Sales will be the Y value. So going into some detail. An explanatory variable is the X variable. It influences, but it doesn't control your data. The response variable, in this case, will be the Y variable, and that's dependent on the X variable. So it does have a large influence on your actual problem. So let me plot this data. So again, for L1, I'm going to plug in price. So I have 2.25. I have 2.54. I have 3.03. I have 2.11. 2.87. 3.06. 2.45. 2.36, 1.96, and 2.66. All right, and then in list 2, I need to make sure 2.25 goes with 760. Back up. 725 goes with 2.44. 555 goes to 303. 725 goes to 211. 680 goes to 287. 615 with 306. 640 with 245. 710 with 236. 685 with 196. And 266 with 610. Okay. Typically, you should try and match up, make sure your data works. Okay, so I can do this. Let's do this. A few things I want to turn on first. So I'm going to exit out of here. So it's got my data still there. I'm going to go into second catalog, And I'm going to go down to letter D for the diagnostics. I'm going to make sure my diagnostics are on. The diagnostics will allow you to see what your R squared and R values are. So diagnostics on, hit enter, done. Once it's on, it's going to stay on unless you turn it off. And then I'm going to go stat. I want to calculate the linear regression off of this. Okay. If I hit linear regression, I could technically type in list 1, list 2. That's good practice if you have multiple things in the list. And it's going to tell you the linear regression. So my straight line equation is negative 1.18 or negative 118.69. So it has a negative slope. My y-intercept is 970.66. My r value is negative 0.69. Okay, notice this is negative. Notice my slope is negative. They both have to match. R squared is not. So R squared is negative 0.69937333622 squared. Okay? Now, if I go back onto my calculator, I can easily say, I want to graph, I want to do a few things. I want to go zoom, stat. So zoom number 9. Whoops, I need to go change that. Under my stat plot, I'm going to change it to a scatter plot rather than a box of whiskers. List 1, list 2. I'm going to use the square dot. I like it. Now I can do zoom 9. That gives me my data. Notice it has somewhat of a line to it. If I want to plot my line of best fit, I'm going to go y equals. Where is it under y equals? Vars. V-A-R-S. Then I'm going to go to statistics, which is number 5. Over to equation, number 1. It's going to plot it in there. We're going to hit graph. It's going to draw me my line of best fit. Okay, so vars. So hit y equals, and then hit vars. Go down to statistics, and then go over to equation. Press enter, yeah. And it'll plug in the equation for you. Okay, so 4.1 scatter plots worksheet, I will make it due on Thursday. So we will have our Chapter 3 test tomorrow. I haven't reviewed. Okay, some of you still owe me some of you still have a quiz you had a smiley face on, so you need some extra time. Some of you haven't even done the quiz yet, so you need to come make that up with me. Some of you still owe me the Chapter 2 test, so you need to come take care of that. But some of you have scores that are lower in the grade book because you're missing so much. So it's now counted against you. Today, I have to leave right after this period, go over to Grandview, down to the Cherokee Trail. I'll be back at 1 o'clock in my office. Tomorrow, I don't have any appointments, so like right after this class, I'll be over in my office. Thursday, I will have a day similar to today, so I will leave right after this class, be back at 1, and then Friday, I'm pretty much open. So that gives you the opportunities when you can, if you need to come by, take care of stuff, all right?